Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on implementing HSRP or Hot Standby Routing Protocol. Alright, so let's go ahead and read our objective for this lab. It says first hot redundancy protocols, FHRPs, are technologies that provide router redundancy and high availability for Cisco networks. There are a number of different HSRPs, each of which differ in scalability and support among vendors. One such HSRP is Hot Standby Routing Protocol. In this lab, you will implement HSRP to learn how HSRP behaves. So if we take a look at our topology, we can see we have two routers, two layer 3 switches, two layer 2 switches, and then we have hosts connected off of a switch 2, and then we have two hosts connected off of a switch 1. Okay, we know HSRP is Cisco proprietary, and we're using Boson, which is really Cisco focused, so that makes sense. So let's go ahead and read our command summaries for this lab. We have configure terminal, which enters global configuration mode from privileged exec mode. We have enable, which enters privileged exec mode. We have end, which ends in exits configuration mode. We have exit, which exits one level in the menu structure. We have interface type number, which changes from global configuration mode to interface configuration mode. We have IP config, which displays the IP address configuration on a PC. We have IP config / default gateway IP address. This configures a default gateway on a PC. We have show standby, which displays HSRP information. We have shutdown and no shutdown. Shutdown disables an interface and no shutdown enables an interface. We have standby group number IP address. This creates or enables the HSRP group with a group number and virtual IP address. We have standby group number preempt. This enables preemption for HSRP on a device. We have standby group number priority. This sets the priority value used in choosing the active router. The default value is 100, and the configurable priority value is from 1 to 255, with 255 being the highest priority. And then we have trace RT IP address, which traces the path from source to a destination on a Windows PC. Okay, so if we take a look, Boson also includes the IP address table for each of the devices, including the device names, the interfaces, the IP addresses for each device, and the subnet mask relating to each device's interface. All right, so we would definitely refer back to this table as needed throughout the lab. But let's go ahead and hop into this lab now without further ado. So we're going to keep our lab topology up here in the top left. We're going to be doing our lab readings in the top right, and we're going to be doing all of our device configuration for HSRP down here at the bottom. Okay, so let's go ahead and get into our lab task. It says task number 1, explore the routing topology. It says in this task, you will explore how packets are routed from one host to another. You will determine from your experimentation how a problem or misconfiguration might affect the network. So number 1, it says on host 1, issue the command to display the IP address configuration. What device is the default gateway for host number 1? So I am going to scroll down to the IP address table so we can reference that. And then the next thing I'm going to do, if I can get, okay, that's what I want. All right, and then on host 1, let's pull that up. So host number 1, we're on host 1 now. And I want to do an IP config just to see our IP address information. And we can see that the default gateway for host number 1 is 192.168.100.3. And if we take a look at our IP address table, we can see that that is the IP address configured for dswitch number 1 for the VLAN 100 interface. So host 1's default gateway is dswitch 1. Okay, so let's go ahead and move on to number 2. It says from host 1, issue the command to trace the route to router 2's loopback 0 interface, which has an IP address of 172.16.1.2. Along what path is the packet from host 1 forwarded? So let's pull up our topology. We can see that host 1 is right here, and we want to do a trace route to the router's loopback 0 interface on router 2. So most likely the traffic from host 1 is going to go up to D switch 1, go to router 1, and then it's going to be forwarded to router 2. But let's trace route it so we can definitely see the exact route. Let's do a trace RT to 172.16.1.2. So we see the first hop was the default gateway for host 1, which is D switch 1. The next hop was 192.168.100.1. If we take a look at the IP address table, we can see that that is the fast Ethernet 10 for router 1. So it went from D switch 1 to router 1. And then the last hop was 203.0.113.2, which should be router 2. Let's confirm. And yes, it is. We can see that that is the fast Ethernet 00 IP address on router 2. So that was the hops that that host 1 took to get to router 2's loopback 0 interface. It went from D switch 1 to router 1 to router 2. All right. So now it says, number 3, it says from host 5, issue the command to trace the route to router 1's loopback 0 interface. What device does host 5 use as its default gateway? So we can see host 5 is right here off of A switch 2. So host 5 is going to most likely take the first hop of D switch 2. The second hop should be router 2. And the third hop should be router 1. But let's pull up host 5 and we can confirm that with this trace route that we're about to run. So let's do a trace RT to 172.16.1.1. All right, so we see the first hop was 192.168.100.4. Let's take a look at our IP address table. And yes, the first hop was D switch 2. The next hop was 192.168.100.2. If we take a look, we can see that that is router 2's fast Ethernet 10's interface. So that's the next hop. And the last hop was 203.0.113.1. And we can see that that is the fast Ethernet 00 on router 1. All right, so the hops that host 5 took to get to router 1's loopback 0 interface was the first hop was D switch 2. The next hop was router 2. And the last hop was router 1. All right, so number 4. It says on D switch 2, issue the necessary commands to disable the fast Ethernet 02 interface. Do you think host 3, host 4, and host 5 will be able to trace paths to router 1's loopback 0 interface now? All right, so let's go on D switch 2. D switch 2, pull that up. Let's do an enable. Let's do a configure terminal. Let's go into interface configuration mode for fast Ethernet 02. And let's do a shutdown to shut down that interface. So now, basically what we just did on D switch 2, the fast Ethernet 02 is the connection up to router 2. So we just severed this link right here. So if we look, the only path for host 5, host 3, and host 4, their default gateway is D switch 2. So any unknown networks for them, they're going to send to D switch 2 because that is their default gateway. But we just shut down this link that D switch 2 uses to get to its default gateway, which is router 2. So if host 5, host 4, or host 3 try to send traffic to networks that are not within their network, they're not going to be able to communicate because we just shut down this link that connects D switch 2 to router 2. Okay, so that is not going to work. It says, will it be able to trace paths to router 1's loopback 0 interface now? And it will not because we just shut down the link that it uses to get to router 1. All right, so number 5 says from host 5, issue the command to trace the route to router 1's loopback interface, which has an IP address of 172.16.1.1. Is the trace successful? Why or why not? The trace should not be successful, but let's confirm. So we can see before it went straight through, and now we're getting asterisks, which means that this destination host is not reachable. It's not able to get out to, once it gets to the first hop of D switch 2, D switch 2 is not able to forward the traffic to router 2 like it was before, and that is because we shut down the link that connects D switch 2 to router 2. So it's going to continue to give me these asterisks. I'm going to go ahead and break out of this by using Control C. All right. And on number 6, it says on D switch 2, issue the necessary command to enable the fast Ethernet 02 interface. So let's go back to D switch 2 and let's do a no shut to bring it back up. So number 7, it says, how might configuring an HSRP like HSRP benefit the network in this scenario if D switch 2 goes down? Well, configuring a FHRP like hot standby routing protocol is going to give us high availability for our routers. So if one or our layer 3 switches. So if one of these layer 3 switches goes down, we're going to be using a virtual IP address. So if one of them, say if the active router goes down, then the backup will be able to take over. So we will have 2 redundant routers, which enables us to have high availability for our network. So we have basically 2 different default gateways. But they will act as one. So if one of them goes down, then the other one will take over for the layer 3 switch that went down, basically. So it gives us high availability and redundancy. Let's see what Boson is going to say. It says by configuring FHRP like HSRP on D switch 1 and D switch 2, you can ensure that every host on the network will have a path to destinations that lie beyond the 192.168.100.0/24 network if either D switch 1 or D switch 2 becomes unavailable. And yes, that is what I explained. It says FHRP or first hop redundancy protocols facilitate layer 3 gateway redundancy. Hot standby routing protocol and virtual router redundancy protocol are both FHRPs. Hot standby routing protocol is Cisco proprietary, and VRRP, on the other hand, is a IETF or Internet Engineering Task Force standard hot standby routing protocol that is supported by both Cisco and non-Cisco devices. It says either a hot standby routing protocol or virtual redundancy routing protocol can be used to configure failover in case a primary default gateway goes down. So yes, that is exactly what I just explained. So let's go ahead and move on to task number 2. It says configure hot standby routing protocol. It says in this task, you will configure hot standby routing protocol in order to provide router redundancy for the network. It says you will then explore how this redundancy helps prevent network downtime. Okay. So number 1, it says on D switch 2, issue the commands necessary to configure hot standby routing protocol on the virtual LAN 100 interface. Use a group number of 100, set a priority of 110, enable preemption, and set an IP address of 192.168.100.254. So on D switch 2, we're already over here. All right, so let's do an exit. And then we want to go into interface configuration mode for the VLAN 100 interface. And then the first thing that it wants us to do is configure a group number for hot standby routing protocol of 100. So let's do a standby 100. And the first thing that we're going to do is we're going to set the priority. So let's do a priority of 110. Okay, let's do a standby 100. Let's do preemption. We want to enable preemption. Let's do a standby. Let's do a standby 100 IP address of 192.168.100.254. Hit enter there. Let's make sure that we did everything correctly. Use a group number of 100, which we did. We set the priority, we set the preemption, and we set the IP address. Looks good. So number 2, it says on D switch 1, issue the command necessary to configure hot standby routing protocol on the VLAN 100 interface. Use a group number of 100, set the priority of 90, enable preemption, and set an IP address of 192.168.100.254. Based on the output you receive after you complete the configuration, what do you think the previous configuration steps accomplished on D switch 1 and D switch 2? So let's go to D switch 1 now. Let's do a enable configure terminal. Let's go into interface configuration mode for VLAN 100. Let's do a standby 100. First thing we want to do is the priority of 90. And I think I typed 200. So let's do a no standby. That was a typo. 200 priority of 90. To take that off, we want to do a standby 100. Fat fingered it, which sometimes happens. I pressed the 2 instead of the 1. So standby 100 priority 90 looks good. Let's do a standby 100 preemption. And let's do a standby 100 IP of 192.168.100.254. All right, and that looks good. So we can see from the output, it says, based on the output you receive after completing this configuration, what do you think the previous steps accomplished on D switch 1 and D switch 2? Well, the first thing we did was the priority. So we were basically electing which router would be the active and which one would be the standby. D switch 2, we configured it to have a higher priority. So we basically configured D switch 2 to be the active router. Okay. The next thing that we did was preemption. So preemption just causes the routers to have an election process if something in the HSRP configuration changes. So that's the case for preemption. And the IP address, this configures both layer 3 switches to use the same virtual IP address. So they can have the standby and active roles, basically. Okay. And then the output on D switch 1, we can see that it is the standby, and it doesn't show on D switch 2, but we can assume that it is the active because we configured the priority to be higher than D switch 1, and we see that D switch 1 took the standby role. Okay. So on number 3, it says on D switch 1 and D switch 2, issue the necessary commands to display the HSRP status. What hot standby routing protocol is configured, and what is the default hot standby routing protocol group value. Okay, so let's do a in and let's do a show standby, and let's do the same thing over here on D switch 1. Let's do a in and let's do a show standby. All right, and the first question was what HSRP group is configured. Well, we can see that the group is group 100 for D switch 1, and we can see that the group for D switch 2 is group 100. And if we do not configure a group, the default group will be 0. But we can configure values between 0 and 255, or 1 and 255, I believe. But let's see what Boson is going to say. It says, based on the output, you can confirm that the HSRP group is 100. Yes. It says to participate in the active and standby routing election process, each HSRP router must be a member of the same group. An HSRP group is identified by a group number between 0 and 255, and the default HSRP group value is 0. And yes, that is exactly what I just explained. So perfect. So number 4, it says, based on the output of the show standby command on D switch 1 and D switch 2, what is the virtual MAC address that is configured by HSRP? What is the role of the HSRP virtual MAC address? So if we take a look, we can see that the active virtual MAC address is 0000 period 0C07 period AC64. And if we take a look at the MAC address on D switch 1, it should be the same MAC address, and it is 000 period 0C07 period AC64. And it says what is the role of the HSRP virtual MAC address, and the role of this MAC address is to respond to ARP requests. So as we know, ARP is to map layer 3 addresses to layer 2 addresses. That is a protocol used to map layer 3 addresses to layer 2 addresses. So it says right here, I'm gonna just read this one because this right here just basically explains the virtual MAC address, which we already looked at on each device. It says the virtual MAC address is used in the ARP process to answer requests for the virtual IP address from other devices, which is what I explained. It says hot standby routing protocol constructs the virtual MAC address differently depending on the version of HSRP in use. For example, HSRP version 1 virtual MAC addresses always begin with 000 period 0C07 period AC, and the last values are the HSRP group number in hexadecimal format. The hexadecimal value of 64 in this case is equivalent to the decimal HSRP group value of 100. It says HSRP version 2 uses a virtual MAC address prefix of 000 colon 0, not colon, period, 0C9F period F dot, where the last three values is the address are the HSRP group number in the hexadecimal format. For example, HSRP group 100 virtual MAC address would be 0000 period 0C9F period F064. Okay? All right. So number 5, it says based on the output of the show standby command on D-switch 1 and D-switch 2, in what state is the HSRP preemption featured on each device? What is the role of HSRP preemption and priority values in the election of the active router? So we can see that preemption is enabled on D-switch 1. Let's go over to D-switch 2. And preemption is also enabled on D-switch 2. It says, what is the role of preemption in priority? Well, the role of preemption is to, if something changes within our HSRP topology, preemption will allow that change to occur. As we know, preemption is not enabled by default on HSRP layer 3 switches or routers. So we have to enable preemption to cause anything to change within our HSRP configuration. And the priority value is used to elect which router will be the active and which one will be the standby. Let's see what Boson is going to say. All right. Yep. So it says right here, because preemption is disabled by default on Cisco HSRP routers, a primary hot standby routing protocol will not by default resume the active HSRP role when it is restored to service. Instead, the primary HSRP router will run in the standby role until it receives no hello packets from the secondary and currently active HSRP router. At that time, the primary HSRP router will resume the active role, and the secondary HSRP will resume the standby mode when it is returned to service. And it says right here, HSRP preemption features enables a standby router to take over the role for an active router. Configuring preemption on a preferred active router will enable that router to always become the active router when it is up. Preemption can also enable a standby router to take over for an active router if the active router priority value changes. Okay? So, on number 6, it says on D-switch 2, issue the command necessary to disable the VLAN 100 interface. What output is displayed on the console after you issue this command? And what state is the HSRP on D-switch 2 after you issue this command? So on D-switch 2, we're going to do a configure terminal. We want to go into interface configuration mode for VLAN 100, and we want to shut down. All right. And as you can see, the hot standby routing protocol has changed. It says state change, HSRP state change. And it says for the VLAN 100 on group 100, it says that D-switch 2 is now in the init state. So it went from the active state to the init state. So that means that it is no longer an active router. It is now in the init state. So let's do a do show. Let's do a do show standby to confirm that. And yes, we can see that the state for this router is now init. And if we go over to D-switch 1, well, let's read the next question first. It says, examine the console of D-switch 1. What new output do you see there? In what state is HSRP on D-switch 1 after you disable the VLAN 100 interface on D-switch 2? So on D-switch 1, we can see that now it has taken over as the active router. So this is what hot standby routing protocol and first hop redundancy protocols do for us. So we seen that D switch 2 is now down, but D switch 1 took over. So because of that, these hosts, we haven't configured these hosts to use the virtual IP address yet, but we can see that if they were configured with the virtual IP address, they would still be able to get out to the internet and do whatever they need to, even though D switch 2 has failed. And that is the enhancement that we get when using HSRP. Okay. So number 7, it says on host 1, host 2, and host 3, host 4, and host 5, issue the necessary commands to change the default gateway to HSRP virtual IP address of 192.168.100.254. So we have host 1 up already. So let's go ahead and make this configuration change on host 1. Let's do an IP config / default gateway of 192.168.100.254. Do the same thing on host 5. Let's do an IP config / default gateway 192.168.100.254. Let's pull up host 2, host 3, and host 4 because we need to make those changes on these client hosts as well. Let's do an IP config default gateway 192.168.100.254. Same thing over here on host 3. IP config / default gateway 192.168.100.254. And lastly on host 4, let's do an IP config / default gateway of 192.168.100.254. Perfect. So now on number 9, it says from host 1, trace the path to router 2's loopback 0 interface, which has an IP address of 172.16.1.2. What device does host 1 send its packets for forwarding? Well, we know that we disabled D switch 2, which was our active. So traffic from host 1 going to router 2 should use D switch 1 as the first hop. So let's confirm that on host 1. Let's do a trace RT to 172.16.1.2. All right, and we can see our first hop was 192.168.100.3. Let's take a look and see what IP address that is, and we can see that that is D switch 1. So that's the first hop. The second hop was 192.168.100.1. That is router 1's fast Ethernet 10. And the last hop was 203.0.113.2, which if we look, that is router 2's fast Ethernet 00. All right. So on number 10, it says from host 5, trace the path to router 2's loopback 0 interface. What device does host 5 send its packets for forwarding? So host 5 should also send to D switch 1, which will go to router 1, and then it'll go to router 2. Because as we know, we disabled the VLAN 100 interface on D switch 2. And now D switch 1 took over. So it is now our active default gateway. So on host 5, let's do a trace RT to 172.16.1.2. And yes, the first hop was D switch 1. The next hop was router 1. And the last hop was router 2. If we look back before we configured the virtual IP address, our first hop was router 2, was D switch 2. All right. But now since we're using first hop redundancy protocol and D switch 2 is no longer active, D switch 1 is our active. So client host 5 can still get out to the internet and do whatever it has to do. So number 11, it says on D switch 2, issue the command to enable the VLAN 100 interface. To what state does first hop redundancy protocol, hot standby routing protocol transition on D switch 2, and then also on D switch 1? So if we re-enable the VLAN 100 interface, D switch 2 should then take back over as the active hot standby routing protocol, and D switch 1 should fall back to the standby, because we enabled preemption and D switch 2 has a higher priority than D switch 1. All right. So let's make sure that we're in interface configuration mode for VLAN 100. Let's do a no shut to bring that back up so we can see it change to up. Let's give it a few seconds, and it should it should show HSRP is active on this router now. Let's see. So I'm not thinking it's going to show us in the console on D switch 2, but if we go over to D switch 1, we can see that it has taken a back seat to the standby mode. It was active, and now it's back to the standby mode. All right, and we can confirm on D switch 2. It didn't show on the console, but let's do a do show standby. And yes, oh, it's still in the init state. So something is going on. It's still showing in the init state for some reason. Not sure why. Shouldn't be in the init state. Let's do an end show standby. Still in the init state. Did I do everything correctly? Did I configure everything correctly? That's weird. It should be in the active mode. It may be an error in Boson because it looks like D switch 1 went to the standby mode. Let's do a show standby. Yeah, so it's showing as a standby on D switch 1, but on D switch 2 it's showing init for some reason. But I wouldn't know what other device would be the active router. All right, let's just do a it says on host 1 and host 5, trace the path from each host to router 2's loopback 0 interface now. To what does each host for this package now? So let's go to host 1. Let's see what it's going to do. Let's do a trace route to that same address. And now it's just showing 192.168.100.2 as the first hop. But it's not finishing the, I don't know if Boson is erroring out right now or what. But I'm not sure what is going on, because 192.168.100.2, I don't even think it's configured. Okay, so it's just going straight to router 2. That's what it's showing. I think Boson is erroring out right now. Yeah, so the first hop here is 192.168.100.1. Huh. That is weird. Let's do a show standby one more time. Yeah, it's in it. Let me hit grade and see what happens. Yeah, so it's showing everything. I configured everything correctly. Boson is just airing out. But if I go back to the lab, it should have been, the first hop should have been D switch 2 for both host 1 and host 5, because that's supposed to be the active router. But Boson is airing out for some reason. So all good. I appreciate you guys for watching this one, and I'll see you in the next one.